Good morning, everyone. We are going to now be studying similarity, and before we can really get into the geometry-specific ideas of similarity, we're going to look at some things that you learned in the past. So, similarity, we can say that two shapes are similar if they have the same shape, but not necessarily the same size. And we saw a lot of similar figures when we were studying dilations in our transformations unit. If you remember, the image was the same shape as the pre-image, but it was not the same size. We use the tilde symbol to designate that two polygons are similar. Remember, that is different than the congruent symbol that we use to designate two polygons to be congruent. Not this time, we're using the tilde symbol. Similar polygons will always have corresponding congruent angles and sides that are in proportion to each other. So let's take that in two pieces. Looking at these triangles, I see that those two angles are congruent. I can also see that they're both isosceles triangles. Therefore, the base angles must be congruent to each other. Well, if I have 180 degrees in a triangle, I've already allocated 80 degrees. There's 100 degrees left over, which means that that must be 50 and that must be 50. Well, this triangle already has an 80-degree angle, so we can use the exact same math again. 50 and 50. All of my angles are congruent. Now let's look at the sides. I want to see if the sides are proportionate to each other. So, looking at this, I've got one side length 4, and he corresponds to side length 2. I've got another side length 4 corresponding to 2. And I've got a side length 6 corresponding with 3. Now if you look, I continually put the bigger triangle on top of the proportion. So the larger one is on top, the smaller one is on bottom. Now, it doesn't matter if I did smaller over larger or large over smaller, but what does matter is that I'm consistent throughout the whole proportion. Well, now I'm going to simplify this proportion. I get 2 equals 2 equals 2. Yes, my sides are proportionate to each other, therefore the triangles are similar. So, we should be able to write an extended proportion to show that all pairs of corresponding sides and proportion are congruent. We did that right here. This was an extended proportion. But let's look down at this one now. Let's see if we can solve for missing values in this triangle. Looking here, it looks like I'm establishing BE equal to WX from right here, or BE corresponding to WX. So that means I want to do larger over smaller. And now I'm just going to list out the corresponding parts. I've got CB corresponding to WZ. I've got CD corresponding to ZY, and ED corresponding to XY. I can now use this ratio to help me solve for things I know. If you look, I've got both BE and WX, so I'm going to use those to help me solve the rest of them. BE is 10, WX is 5. Well, let's look at the side CB over WZ. Well, CB is 6, WZ, we don't know, is X, or I'm going to call it, I'll leave it as WZ. Well, to solve this, I can cross multiply. I'm going to do to the side over here where I get 10 times WZ equals 30, and solve. WZ must be 3. You did this in your proportions quiz for homework, so hopefully this is very familiar. Now let's look at the next pair of sides. I've got CD over ZY. Well, CD is 15, and ZY, I don't know what ZY is, so I'm just going to put ZY down as my answer. I want you now to go through and solve for ZY on your own. I'll show you the answer at the end. Now let's look at the last one. I've got ED over XY equals BE over WX. Well, ED, I don't know, so I'm just going to put ED up here. And XY, I do know, is 4. So, just like before, cross multiply. I get 40 equals 5 times ED. So, ED must be 8. We also can say that there is a scale factor that describes the relationship, which can be found by taking the ratio of the corresponding sides. So that 10 over 5, if I reduce that, I get my scale factor, which is 2. So we can determine if two polygons are similar by looking at a number of different factors. The first one is if all of their corresponding angle measurements are congruent, or we can look to see if the corresponding sides are proportionate to each other using the extended proportion. Or we can look to see if the scale factors between each of the corresponding sides is the same. So now let's take a look and see if we can determine whether or not these shapes are similar. So looking here, I have two shapes. I only have sides, so I can't use number 1. I think I'm going to write out my extended proportion for this one. So I'm going to start here with 9 over 6. I'm going to do big over small again just because it's written nicely. Then we have 8 over 7. Then 12 over 8. And 6 over 4. 4 over 3. And now I'm going to simplify all of these fractions. So this becomes 3 over 2. 8 over 7 does not simplify. This becomes 3 over 2. 3 over 2. 4 over 3. Looking at this, it's not always the same. Therefore, the shapes are not proportionate, or not similar. Okay, now let's do our last one here. I'm going to use scale factors this time, and be very careful. They're in different orientations. So what I really need to do is look at the longest side and the longest side of each shape, the middle side and the middle side, the shortest side and the shortest side. So looking, my longest side on my bigger triangle is 65. The longer side on this triangle is 52. So I'm going to find my scale factor, 65 over 52, which gets me 5 over 4. Okay, first scale factor, good. Now let's look at the middle side. 55 over 44. Well, that also reduces to 5 over 4. Looking good so far. Now let's look at my last one. 30 over 24. Well, wouldn't you know, that also reduces to 5 over 4. So, yes, they are similar. Thank you very much. I'm now going to show you the answer to the one problem I asked you to do on the previous page. You should have gotten that ZY equals 7.5.